Hey guys, we were looking at the determinants of 3x3 matrices as we develop them through Cramer's rule. Keep in mind that there are two methods. There's the delicious, rich creme brulee method. I don't know if I spells this right. Then there's the cheap Pop-Tart method. Kind of leaves you unfulfilled. Okay, whatever. And we're doing the cheap Pop-Tart method. Hey, at least it's raspberry, a good choice there. All right, the determinant is a value. It is not a matrix. The determinant of a matrix is not a matrix. It is a value. It's just a number. We have seen that over and over again with 2x2 matrices. And now we're just moving on to 3x3 matrices. And the setup is going to be the same. Let's go through it anyway. All right, and so if we were going to set this up for y, then we would copy, we would set up the denominator. Let me slow down a little bit. Set up the denominator, 1, 2, 1, 1, 2, 1, negative 2, negative 1, 5, negative 2, negative 1, 5, and then the z coefficients would go in over here. And so we would take this and we'd copy it to the top, okay? Well, if that was the case and we were to just leave it like that, then of course the answer would be 1 because anything divided by itself is 1. But then we want to take out the y coefficients because we are solving for y. See if I can get this to work. Yay. And then put in the constants. These are the constants. 9, negative 4, 0. And then that's it. So you may want to pause the video. We just saw that. Pause the video and see if you can solve this or set this up for z. It would be the same idea that you would take this to the top and you would take out these coefficients and put them in right there. All right, let's move on. So you should be able to recognize this answer. You may want to pause the video and see if you can come up with that. Let's get rid of all the distractors just because I like doing this. A lot of fun for me. I get very little fun. Okay, and then so we want to keep in mind that there's a 0 in this equation, and that's why we have that 0 right there because we don't have a z coefficient in the first equation. So you would have to put those in there. Okay, and then we would copy that to the top. We would take out the z's. Whoops, the y's. We are solving this for y. It helps to pay attention. So solve this for y. And then we would put in the constants 12, 0, 15. Okay. Have another one of these. Might want to pause the video and see if you can recognize the answer. I believe it is F. Keep in mind we have a 0 coefficient of 0x there. So, that is an issue. Okay, so the trick becomes, how do you find the determinant of a 3x3 matrix? Well, we're doing it the cheap Pop-Tart method here. All right, this is what you would do first. You copy the first two columns at the end of the matrix. So this column goes here. I'm just copying it. And this column goes here. And I'm just copying it. So we kind of enlarge the matrix. And then it would look like that. And then we want to multiply the positive diagonals. I'm calling these diagonals positive. Okay. And you just multiply it. So on this diagonal, we multiply the elements. 3 times 2 times 1. Yes, that is 6. Multiply these elements. Negative 2 times negative 3 times negative 1. That's 6 as well. And then multiply these elements, which is, I just wrote them out instead of multiplying them. Okay, and then we want to subtract. This is a pretty key symbol right here. Subtract the sum of the products of the other diagonals. Okay, so this red diagonal right here are those numbers. This red diagonal are those numbers, and then these numbers. And then it's just calculated. You may want to pause the video and see if you can calculate that because we have it. That is the determinant. Okay. And so that would be number 3. Keep in mind when we're at Socrative that number right there matters. That if I refer to problem number 3, I'm talking about this one. And so hopefully you've already come up with that it's negative 38. You can do it in pieces or just type the whole thing into your calculator. It doesn't matter to me. Okay. I like to do the blue pieces and then the red pieces and get them down to blue, red, and subtract. Kind of that idea. All right. Pause the video and see if you can come up with the determinant of that 3x3 matrix. All right. That's what I came up with, that you do these diagonals first. Is the sum of products, and then the red diagonal second, and you subtract those sums of products. Anyway, the answer is negative 50. All right, again, it's just another one. Once you get a procedure down, it's like, well, how many times do you need to do this to master the procedure? And that's what we're trying to do. There's the answer. Number 37, 37 is the answer. Okay. And then there's number 6. I'm not going to give you the answer to that one. That's going to be part of the assignment. You have to come up with the determinant. You can collaborate with your friends if you need to, or you can go on your own. That is the end of the video. We do have a cameo appearance. I like a cameo. Drum roll. Cameo is Admiral Nimitz, who was a key figure in World War II and the development of our submarine fleet. Anyway, they named a aircraft carrier after him. Big man in the Navy. We're proud of him. All right, guys, that's it. We'll see you